Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. Okay, so we are actually now at the end of our topic for this semester's topic 10, application of differentiation, and now we look into the first part, which is for 10.1, extremum problem. Okay, we are going to discuss or analyze a kind of, we call a function. Mostly is a graph of what we call a curve, whether it's quadratic or cubic, and we're going to look into the definition of stationary point, critical points. Okay, so then please refer to your lecture notes. So we are going to focusing on the critical points, to find the relative extremum using the first derivative test, and find the relative extremum using the second derivative test. For optimization problems, we're going to call in the second part of our lecture for chapter 10. Okay, now a function fx has a critical value at x equal to c if fc is defined and f prime c equal to 0 or f prime is not defined, then we call it as a critical point. Never mind, we're going to look into the example that makes it clear and read this all definition here. Okay, stationary point f prime x or dy dx, okay, equal to 0 at the point of x equal to c. Okay, if I make it something clear with the x and also y axis. Okay, let's say this is the curve of y equal to fx, and this is quadratic. Okay, now we are going to look at this point here, okay, where the gradient, this gradient or dy dx equal to 0. So at this point we refer to the x-axis and also y, where this is what we call the coordinate of x equal to c, and this is the coordinate of y or fx, where x equal to c. So this is the coordinate of c, f, c. Okay, and at this point f prime x is equal to 0, just like this one here. We call the dy dx is parallel to the x-axis. Okay, A, B, and C are called stationary points, and dy dx, because it is not equal to 0, then we are not. This is not one of the we call the stationary points in this graph. Okay, so find critical point where fc is defined. So look at this one here, when f prime with a function when x equal to c, make it equal to 0, it is a critical point and also stationary point. But when it's f prime c is not defined, then it's just a critical point. Okay, look at example 1 here. Y equal to x squared minus 1 to the power of 1 over 3, then y prime or dy dx. Okay, y prime we also define, okay, represent the dy dx is just the same. Okay, y prime equal to 1 over 3 x squared minus 1 power of 1 over 3 minus 1, then come up with negative 2 over 3, and differentiate x squared minus 1 to x. Okay, so then 2x divided by 3x squared minus 1 to the power of 2 over 3. So then let's make it y prime equal to 0, or 2x divided by 3x squared minus 1 to the power of 2 over 3 equal to 0. Cross multiplied here, then simplify this, we found that x also equal to 0. So when x equal to 0, then we substitute into the function of fx or y here. Okay. When x equal to 0, then y substitute x equal to 0 here. Okay, 0 square minus 1 to the power of 1 over 3. So 0 square minus 1 and negative 1 power of negative 1 over 3 equal to negative 1. So the coordinate, one of the coordinates here, critical points here is 0 and negative 1. Okay, by the way, dy dx is not defined, okay, when x squared minus 1 equal to 0. Okay, it's not defined when x squared minus 1 equal to 0. From here, x squared minus 1 equal to 0, then x minus 1, x plus 1, so then x equal to plus minus 1. So we call divide into two parts here. So when x equal to negative 1 and also when x equal to 1. Okay, now when x equal to negative 1, again, use the formula, we call the function given that y equal to x squared minus 1. And here come up with y, negative 1 equal to negative 1 square minus 1 to the power of 1 over 3. Negative 1 square equal to 1. 1 minus 1 equal to 0. So then come up with the coordinate of negative 1, 0. And when x equal to 1, again, we substitute into this formula of the function y, where x equal to 1. X equal to 1, then come up with 1 square minus 1 to the power of 1 over 3. 1 square is 1 minus 1 equal to 0. Then we get another coordinate which is 1 and 0. So we collect all these three coordinates. Then we come up with a conclusion that the critical points are negative 1, 0 here, and then 0, negative 1 here, and next is 1, 0. There you go. Okay, before that, these all the critical points of negative 1, 0, 0, negative 1, and 1, 0. Okay, let's try. Okay, the function of here, the function of this, y equal to x squared minus 1 to the power of 1 over 3. How do you say this? Y equal to x squared minus 1 to the power of 1 over 3, and the critical points okay, we list all everything just now. We list 0, negative 1, 1, 0, and negative 1, 0. Let me share with all of you the graph of this. Okay, so look at this one here now. The graph of y equal to x squared minus 1 to the power of 1 over 3. So the graph is something like this, and this is the coordinate of 0, negative 1. This is the coordinate of negative 1, 0, and 1, 0. So this is a gradient where it is positive, negative, gradient negative. So they say we call where reflecting the point here, and this is where the gradient equal to 0 and all that. Okay, then find the stationary points for x cubed minus 3x squared plus 6. So then y equal to x cubed minus 3x squared plus 6. Okay, and now here we find that the dy dx or y prime equal to 3x squared minus 2 times 3 equal to 6x. Okay, so then here let's make this one dy dx, make it equal to 0. 3x squared minus 6x equal to 0. Factorize this, then come up with 3x x minus 2. Okay, from here, from these two, we come up with the conclusion that the value of x equal to 0, then x equal to 2. By the way, we are going to find out what we call the stationary points of this. When x equal to 0 and when x equal to 2. Okay, when x equal to 0 and x equal to 2. So substitute x0 into the function of y. y0, which is x equal to 0, 0 cubed. Negative 3 times x squared, so negative 3 times 0 squared. And plus 6, then y0 equal to 6. So that the coordinate of the stationary points here is 0 and 6. And then when x equal to 2, then y2 equal to, here, 2 cubed minus 3 times 2 square plus 6 equal to 2 cubed equal to 8, 2 square equal to 4 times negative 3 minus 12 plus 6. Okay, negative 12 plus 6 equal to negative 6. Negative 6 plus 8 and equal to 2. Then the coordinate is 2 and 2. So now the final answer, the stationary points are 0, 6 and 2, 2. Okay, next, types of stationary points where f prime x equal to 0, then there's we call the conclusion whether it's a maximum point or minimum point. And then come up with extremum. Step to determine the extremum points, f prime x equal to 0, and we test with the first derivative test or second derivative test. Okay. First derivative test relative maximum point. Okay, the curve will be something like this. Okay, this is the coordinate. This is the coordinate of dy dx equal to 0. Horizontal line touch at the peak of the graph. Okay, the curve is something like this. And then at this point, at the peak of the curve or the mountain, there is we call a place where it is a gradient equal to 0 or horizontal gradient. Okay, the gradient is horizontal. So when dy dx equal to 0, when x equal to c, before, okay, before this point, this is where the gradient, gradient is positive. Gradient is greater than 0, positive. And then after that, y increase, and after that, dy dx is less than 0, where whatever we call the value of y is decreased. It's just like a curve of a quadratic. Okay, maybe something like this. Oh no, sorry, wrong example function for this part. Okay, let's say this is a curve. Okay, at this point where it is y increase, at this point where the gradient equal to 0, and at this point where the y decrease or y prime is negative, and here is where y prime or dy dx which is positive. Okay. First derivative test, relative minimum point, just like the previous one here, where point of C and FC or y, x and y relative minimum. Okay, before this point where dy dx is less than 0 or negative, and here where dy dx equal greater than 0 or it is positive. Okay, so you can see here now, let's say this is the border of x equal to c. So before the point of x equal to c, before it, then f prime x from positive to negative, or interchange from negative to positive. So this is a maximum point and minimum point. The gradient which is positive, gradient positive, something like this, and then going down. So it's a maximum point, the peak of the graph. And from here the gradient is negative, then turn out to positive. So then this is the lowest point or the valley of the graph. Okay, second derivative test. Let y equal to fx and f prime c equal to 0 or dy dx equal to 0 when x equal to c, and f double prime exists on an open interval containing c. Okay, fc is called extremum value. If the second derivative of y equal respect to the x, second derivative less than 0 or negative, then x is equal to c, then this is a relative maximum point. And okay, opposite of this, if dy second derivative y respect to the x greater than 0 or positive, at x when x equal to c, there is a relative minimum point. Opposite, positive with a minimum point, where it's negative or less than 0, they come up with maximum point. Okay. Example 3. So find the relative or maximum for y equal to x cubed minus 3x squared plus 6 by using the first and second derivative test. So then y prime or dy dx, y prime dy dx or f prime, it's all just the same. It's just we call the symbol represent that dy dx or first derivative. So then dy dx equal to 3x squared minus 6x. So factorize this, make it equal to 0. So then when dy dx equal to 0, then 3x squared minus 6x equal to 0, then 3x with x minus 2. Okay, so we got two values here, x equal to 0, then x equal to 2. Okay, now, when x equal to 0, then substitute into the function of y 0 equal to 0 cubed minus 3 times 0 squared plus 6 equal to 6. So then coordinate or at x 0 and y equal to 6. Okay, and let's say if I bring more further here, where x equal to 2, then y with 2 here equal to 2 cubed minus 3 times 2 squared plus 6. 2 cubed equal to an 8 minus 2 squared is 4 times 3, negative 12 plus 6. So 6 minus 12, negative 6, negative 6 plus 8, then come up with 2. So then the coordinate of 2 and 2 here. Okay. Then using the first derivative test, using the first derivative test, so if I divide it into 3 parts here, negative infinity until 0, where x equal to 0 here, and then 0 until 2, and 2 to positive infinity. Okay, so then this is dy dx. Okay, and also fx. Okay, second derivative, dy dx equal to 3x squared minus 6x. Choose any value of x that lies in this range, 0, negative infinity until 0. Let's make this, we call our life easier, let's make this one with negative 1. Because this x equal to 0 and this x equal to 2. So, from negative infinity until 0, choose any values lies in this range. And of course, I can choose negative 1 here. Okay, so negative 1. Okay, negative 1 squared. Y prime with negative 1, which is 3 negative 1 squared minus 6 times negative 1. Negative 1 squared is 1 times 3, negative 1 with 6, positive 6. 9, positive. It is positive then. Okay, and then y prime where x equal to, okay, let's say any numbers lies in between 0 until 2. I choose 1. Okay, 1 here, then again dy dx, 3 times 1, oh no, minus 6 times 1, okay, 3 minus 6 equal to negative 3. Let it know, look at the sign here, which is negative. And then y prime, and any values of x between 2 to positive infinity, I choose the nearest one here, which is 3. So 3, then 3 times 3 minus 6 square, minus 6 times 3. 3 squared equal to 9. 9 times 3 is 27 minus 6 times 3 equal to 18. Okay, 27, which is 9 here, positive. Okay, and come out with positive. Okay, so if we substitute the value of negative 1 into the function of fxy, it's gonna give you a graph of increasing, decrease, and increase. Okay, class, I think that I make a mistake here. It's a f prime. Okay, dy dx is a f prime, and actually that this is a sign of f prime. Okay, the sign of f prime x, whether it's an increase, decrease, and increase. Okay, just imagine that if this is the f prime, the sign of f prime, or we call increase and decrease, that we call the gradient, is just like something like this. Okay, at this point where x equal to 0 and x equal to 2, this is the stationary point where dy dx equal to 0, and also here dy dx equal to 0. Before, then the f prime is in the positive, increase, decrease, and increase. Okay. Okay. So we'll discuss, or look at the first derivative test. And now, okay. Actually, that is I show you all of this. Okay, here. Okay. Never mind. Make it again. This is from 0 and negative infinity until 0. From 0 until 2, and 2 to positive infinity. Say sign of positive, negative, and positive. And then fx equal increase, decrease, and increase. Okay, second derivative test. From y equal to x cubed minus 3x squared plus 6x, and then y prime or dy dx equal to 3x squared minus 6x. And we make this one y prime equal to 0, where 3x squared minus 6x equal to 0. Factorize 3x, then x minus 2. Then we get here x equal to 0, and x equal to 2. Okay, then from y prime, then we come up with y double prime, or second derivative of y respect to the x. So from here now, 2 times 3 equal to 6x. 6 derivative of 6x divided by 6x, then negative 6. Okay. Now, let's make this one here y prime or second derivative. Use the value of x equal to 0 first. Okay, second derivative or second derivative of y respect to the x, or y double prime, which is 6x minus 6. But then this x, we substitute the value of x that we get from the y prime equal to 0, which is 0 and 2. So y double prime 0 here, 6 times 0 minus 6, then you come up with negative. Okay, when you come up with negative here, which is less than 0, then 0 and 6 is a relative maximum point. Okay, and then y double prime x equal to 2. This value of x 0 and 2 from the y prime equal to 0, then substitute into the second derivative. 2 here now with 6 times 2 minus 6. 12 minus 6 equal to 6, which is greater than 0. So we come up with the conclusion that the point, the coordinate of 2 and 2 is a relative minimum point. Okay, so okay, class, guys, my students, please refer to some other lecture notes or reference book as an additional, and hopes that this video helps you to continue with your tutorial. And that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. and have a nice day.